everyone. In the last video we have studied about current and drift velocity, and in this video we are going to discuss about current density along with the relation between drift velocity with current or current density. First of all, current density means, actually density means we used to go with volume, but for current alone we used to take only the area, because I already told you the current depends upon the number of electrons entering and leaving the conductor. It does not depends upon the total volume. Whatever may be the length, the area is going to decide how much electrons is going to enter, how much electron is going to leave, right? So now that's why we are going to define the current density is nothing but electric current per unit cross sectional area at any point in a conductor. So I can able to write J is equal to I by A. I is nothing but the current flowing through a conductor, and A is nothing but area. So the unit is nothing but ampere meter to the power minus 2. And the current density is nothing but vector quantity I is equal to, suppose I want to find out from here. So if it is given I, that is J is nothing but non-uniform, I can able to integrate and find the value. So I is equal to integration of J vector dot dA vector, and I can able to take the area is nothing but vector quantity in the case of microscopic level. Microscopic means very small area can be taken as vector quantity, and very important, the area is always normal to the plane. That's what you are going to take in the current density. Whatever the area you are going to consider, that should be normal to the current. Okay, the next one is nothing but relation between drift velocity and the current. For that purpose, I have considered a particular conductor here. So we are going to give the particular supply. You can take the supply is given as a EMF E. Okay, so now the length of the conductor L you can take, and the area of the conductor is nothing but A. So here the protons also available and the electrons also available. Okay, so when I am giving the external electric field, the electrons will be moving toward this side with the velocity called drift velocity, and the proton will be moving towards the negative side of the battery, and the electric field applied will be in this direction, and current is also in this direction, and the current density also in this direction, but the particular velocity, that is drift velocity alone, will be in the opposite direction. So hence the current will be moving in the circuit, that you can take it as I. So we know the general formula, I is equal to what? Q by T, right? I is equal to Q by T. So now I am going to take it as that I, first of all I want to find out Q. So Q is nothing but total number of electrons into charge carried by one electron. So N is nothing but total number of electrons, that's nothing but charge, that is number of electrons per unit volume into area into length. Area into length is nothing but volume. So I can able to replace this formula as nothing but I is equal to N into A into L E divided by T, right? So here L by T, I can able to write drift velocity Vd is nothing but L by T. So I can able to write this nothing but I is equal to NAEVD. Okay, so this is the formula for current, and the drift current density is nothing but J is equal to I by A. So I can able to write this nothing but what? NEVD. This is the formula for what? Drift velocity, that is current density by using drift velocity. Okay, so we know the formula Vd, that is we know that Vd is equal to what? Mu into E, right? So if we substitute the value of mu E, what will get? I is nothing but N into A into E into mu into E, right? So we know the formula for mu, already we studied in the last video, that is NAE into E tau divided by M into E. So I can able to write I is nothing but NA E square tau divided by M into E. So this is the formula for I in terms of E, right? So now I am going to write the next one with respect to current density. J is nothing but, I can able to write only A you have to eliminate. So you will be getting like this, and this can be written as J is equal to sigma into E, where sigma is nothing but electrical conductivity, that is equal to Ne squared tau divided by M. And you know that rho is nothing but electrical resistivity, that is 1 by sigma, that is equal to M divided by Ne squared tau. Okay, so these are all the very important formula. From here I can able to write J is directly proportional to what? Electric field what I am applying, okay, and sigma formula and rho formula. Okay, so now the next one what we are supposed to study is we can able to relate this with the semiconductor. What is semiconductor? Here the current is due to both electrons and holes, right? So I can able to write I is nothing but IH plus IE. So you can able to write IH is nothing but N into E into like A into Vd, right? So I'm going to write Vh, so number of holes, velocity of holes. Similarly, number of electrons into E into A into velocity of electrons. Okay, so this is the basic formula for semiconductor, what you are supposed to use it. Okay, this can be written as with respect to what? Mobility also. So if I'm going to write with mobility, E and A are common, I can take commonly out. You can able to get NH mu H into E plus Ne mu E into E. Okay, this is the very important formula, that is it's giving the relationship between what? Drift velocity with current or current density. Okay, so if you go through this, you can able to answer for one question compulsorily in the Neet JEE exam. Thank you.